for homework packet 3B. So let's flip to the second page and let's do problem number 9. Problem number 9 is to find the area of the shaded portion. So the goal is to find the area. What do you see? Draw it, right? So we've got something like this, and we've got some hole like that. And what else do you see? I see 6 here. Do you see it? I see 3 here, 8, 3, 7, and 9. And I see the shaded portion is like here. Do you see the same thing as mine? Do you also see 3 rectangles here? Right? Do you see 6 by 3 rectangles? Do you also see 8 by 3? Right? If you cut right there, then I'll see 8 by 3 rectangles. Right? And I also see the big rectangle, which is 7 by 9, or what? 9 is from here to here, right? What's from here to here? That's 3, right? Because this is the rectangle, and opposite side of the rectangles are congruent. So I see a big, tall rectangle, which is 7 by 12. We know how to find the area of these rectangles by multiplying base times height. But what can we do? Our goal is to find the area of shaded portion, this green part of it, right? Without that part, without the part in the middle. We have a hole of that. So what can we do with these to find that? Moving on, let's look at lesson 3.07, 8, problem number 9. Give each value for the right triangle shown. A is the height from vertex A to base segment BC. So the goal is to find the height for part A, area of the figure for part B, and C, I want you to do it by yourself. I'm not going to give you any hint. So what do you see? What are the givens? The givens are, we are talking about triangles. Do you see the triangle? I see A, B, and C here. Do you see it? And I also see 5 centimeter, 3 centimeter, and a 4 centimeter. Okay. Do you also see 90 degrees here? Good. So let's think about what the height means. The height means that the distance from a point to a segment. So meaning that the shortest way from the point to the segment, like this. Okay. It can be slanted. The height will be the point to the segment, shortest way of going there, which is always 90 degrees. So let's erase this EC for now. Okay. What is the way? What is the quickest way? What is the distance? What is the quickest way from vertex A to segment BC? Right? Goes 90 degrees. What are the distance? This is pretty easy problem. So that's part A. Part B is to find the area of the triangle. As you know, area of the triangle is half of base times height, or base times half of the height, or base times height, and make it half of it. So in this case, base is either 3 and height is 4, or vice versa. But base is not the 5. The base doesn't always sit horizontally. It's just a relationship. Do you have base and height intersecting 90 degrees or perpendicularly? That is the base and height, not the segment that sits horizontally. All right, that was